Hello everyone, I'm Rudra, a smart contract triager from Immunefi, the leading bug bounty platform for Web3. In this video, we'll learn about a simple yet significant vulnerability in Web3 about access controls, as well as how to identify and fix such issues. So, what are we waiting for? Let's get started. On April 22nd of this year, whitehat submitted a critical vulnerability in Sense Finance via Immunefi. This vulnerability consisted of a missing access control issue in the onSwap function of the Sense Balancer pool, which could have allowed a malicious actor to update the Oracle data of the Space AMM contract. So if you are interested in reading more about this vulnerability, you can find our bug fix review in the description of this video. Sense operates as decentralized, permissionless infrastructure where teams can build and develop new yield primitives for DeFi, such as bond-like assets, yield tokens, and trends-like instruments. An access control is a method of restricting access to a smart contract function so that only an authorized user can execute these functions. In other words, it prevents malicious actors from accessing critical functions like mint, which allows users to mint new tokens for an address. Modifiers in smart contracts are conditions that must be met for a function to get executed. One such modifier is onlyOwner, which verifies whether the function's caller is the smart contract's owner or a member of an authorized group. This contract is an illustration and contains two variables: owner, which represents the address of the owner who deployed the contract, and win, a boolean variable that indicates whether or not we were successful in calling the function. When a contract is created or deployed, a particular function called a constructor is invoked. In this scenario, we set the owner variable to message.sender, which is the address that initiated the function or a transaction. This address could be a smart contract or an EOA, externally owned account, are controlled by a public or private key pair. There are also contract addresses which are controlled by the code written inside the contract. In the next line, we created a modifier that checks if the value of message sender, which is the address that is calling the function, is equivalent to the owner variable, or else it will throw an error indicating not owner. The special symbol or pattern _semicolon indicates that the body of the function to which the modifier is attached will be inserted. Lastly, there is a function name onlyAdmin, which is a public function with the modifier onlyOwner that verifies that the callee is indeed the owner of the contract and sets the win variable to true if the modifier conditions are satisfied. Let's understand what happens if we remove the onlyOwner modifier from the onlyAdmin function. As the function is public, anyone on the internet who calls it can set the value of win to true, because we are not checking for access control. As a result, it's important that we implement an access control system to secure sensitive functions. We can also add the conditional check directly in our functions, but it makes the code messy and lengthy. The code still works the same and checks whether the callee is the owner of the contract and throws an error otherwise. To understand what Sense Finance is, let's first understand what AMMs are. Automated market makers are decentralized exchanges that pool liquidity from users and price the assets within the pool using algorithms. The exact mechanics vary from exchange to exchange, but generally, AMM offers deep liquidity, low transaction fees, and 100% uptime for as many users as possible. SenseSpace is also an AMM contract developed by Sense Finance, which is built on top of Balancer v2. Balancer is an automated portfolio manager, liquidity provider, and a price sensor. For more details on how Balancer works, check out the Balancer's blog post in the description of this video. When the Balancer Vault performs a token swap, it will call the onSwap function in the Space AMM pool to determine the output amount based on the token balances. In addition to the reserved information provided by the Balancer Vault, the callback updates the stored Oracle information on the pool contract. Oracles are the data feeds that brings data from off the blockchain data sources and puts it on the blockchain for the smart contracts to use. This is necessary because smart contracts running on the Ethereum cannot access the information stored outside of the blockchain network. Giving smart contracts the ability to execute off-chain data inputs extend the dApps value. For instance, there are multiple cases where we would need to know about the current prices of Ethereum, and for that, we can use price oracles. If we closely examine the onSwap function of the Sense AMM contract, we can see that the function does not have access control implemented, meaning that anyone can call the function and provide the price information, and the oracle would have set into that state. The oracle will then read the price as having been recorded arbitrarily in the past or the future. Looking further, we can notice that the pool contract has a only vault modifier, which allows calls from balancer vaults. This modifier has been placed on onJoin and onExit function, but was missing on onSwap function. The project fixed the vulnerability by adding a check that verifies if the callee of the function is balancer vault or not. The if statement verifies that the message sender is the address of the vault, and if not, the function will not be executed. We would like to thank the whitehat for finding this bug and responsibly disclosing it through Immunefi. Stay tuned and subscribe for more videos from Immunefi.